Okay, today we're looking at graphing polynomials. Now, if your polynomial has an even degree, which means degree to the power of 2, degree 4, degree 6, and if the leading coefficient is positive, for example, it might be 3x squared or 5x to the power of 4, not negative 3x squared, not negative 5x to the power of 4. So if the degree of your polynomial is even, like 2, 4, 6, etc., and the leading coefficient is positive, so you might have something like 3x squared, 4x to the 4, I don't know, 7x to the 6, okay, so they're not negative, then the polynomial will be positive as the absolute value of x becomes large. In other words, as x approaches infinity, your polynomial will go up. As x approaches negative infinity, that's why we've got absolute value of x. As x approaches negative infinity, the polynomial goes up. So both bits go up. Can you see that? So if it's even. So this means that for any polynomial with positive leading coefficient and even degree, the polynomial of x approaches infinity as x, so this goes up as x approaches positive infinity, and as x approaches negative infinity, the end bits of the graph both go up. An x squared type, y equals x squared type. That is not exactly y equals x squared, because you can see the shift. See how you can see the shift? X squared looks like this, but this might be x squared. As we were saying, if you've got an even degree, as in an x squared, an x to the power of 4, or an x to the power of 6, okay, type of graph, both ends of the graph will go up. Look, 1, 2, x squared, x to the power of 4, 1, 2, 3, 4. X to the power of 6, 1, 2, 3, 4, 5, 6. But you start from the top, go down, down, etc. All right, so both ends are up. Both ends are up, both ends are up. Okay, now, even degree, but negative leading coefficient. So again, if you've got, if the degree of your polynomial is even, as in you've got x squared type, x4 is your leading, if your degree is x to the power of 4 or 6, but your leading coefficient is negative, so you might have negative 3x squared as your leading term, or you might have negative 4x to the 4, or you might have negative 5x to the 6, etc. Okay, then the polynomial will be negative as the absolute value of x becomes large. Now, you already know y equals negative x squared looks like this. Okay, so negative, this is negative x squared type. It doesn't mean that it's just y equals negative x squared, all right? It would be negative x squared, maybe minus x or plus x or something like that. But you just look at the leading coefficient for the shape, okay? This is a y equals negative x to the power of 4 type of graph. This is a y equals negative x to the power of 6 type of graph. But there will be other terms in it, okay? So then the polynomial will be negative as absolute value of x becomes large. So as x approaches positive infinity, the polynomial approaches negative infinity. As x approaches negative infinity, the polynomial also approaches negative infinity. In other words, they're down shape. All right? So on the graph, both ends of the graph will go down. Okay? How do we know this x to the power of 2 type? 1, 2, 1, 2, 3, 4 for the x to the power of 4 type. 1, 2, 3, 4, 5, 6 for the x to the power of 6 type. But that's a negative x to the power of 6, upside down, right? If you've got an odd degree and a positive leading coefficient, so if the degree of the polynomial is odd, so you might have x to the power of 1, x to the power of 3, x to the power of 5, etc., and the leading coefficient is positive, you know the y equals x, that's a straight line, right? And the leading coefficient is positive, so you might have, I won't worry about my x to the power of 1, I might go 2x cubed type, 4x to the 5 type, etc. Then the polynomial will be positive as x becomes a large positive value, and the polynomial will be negative as x becomes a negative large value. Look, I know, see this x cubed type like this, there are other x cubed types that look like this as well. All right, so this is the graph of x cubed that you know, 1, 2, 3, but other types are like this, and we have seen ones like this, right? So this is like a y equals x type, Might be y equals x plus 2, y equals 2x plus 2. These are y equals x cubed types. And this is a y equals x to the power. Look, one's got to go up, one's got to go down with this type because you go 1, 2, 3. Does that make sense? You can't have them both going up or both going down because you need an even power for that to happen. So here, this is an x to the power of 5 type. So one end of the graph on the left-hand side is down and the other end of the graph on the right-hand side is up. So you start from the bottom, up, up, down, up. See? 1, 2, 3, 4, 5. All right? But that will happen because it's odd power. One will be up, one will be down. And this type goes like this, 1, 2, 3. All right? So that is odd degree. So x cubed type, x to the power of 5, 3 type. Sorry, x to the power of 5 type, x to the power of 7 type with a positive leading coefficient. Then you can have an odd degree and a negative leading coefficient. So if you've got an odd degree like x to the power of 3, x to the power of 5, but a negative leading coefficient such as negative 2x cubed, negative 4x to the 5, negative 6x to the 7, etc., then it starts from the top and goes down. It's just, how do you know? You just think of your negative gradient of a negative line. Gradient of a negative line. That's an odd power. This is an odd power. This one's actually the graph of y equals negative x cubed, but you can also draw this type of graph there as well. And this is a negative x to the power of 5 type graph. 1, 2, 3, 4, 5. So instead of starting from the bottom and going up, they start from the top and go down. Okay? So on the graph, the end of the graph on the left-hand side is up, goes up, but the end of the graph on the right-hand side goes down. All right? All right. This is a polynomial, the first one. So we're just going to sketch single and multiple roots. So we're going to sketch some single roots, double roots, and triple roots in a minute. Now, these are all single roots because it's just this polynomial. Can you tell me what degree it has? Yeah, if you multiply the x terms by each other, its degree is 3. So the degree is 3. It's got an x cubed is its highest power term. Okay, would you say it's a positive one with degree 3? If you multiply the x's together, you get positive x cubed, so it's a positive degree 3, which means that the shape is like this. Okay, so the shape is like this. But I also, and it will cut, what are my 3 x-intercepts? So my x-intercepts are 1, negative 2, and 3. So I've got 3, 1, and negative 2. They're my x-intercepts. Look, I could actually sketch as well. I should really actually put where the y-intercept is as well, but we're just looking at where the roots are. So it's this shape. Are you okay with that? It's that shape. Okay, if I multiply the 3 constant terms, what do I get? 6. Negative 1 times 2 times negative 3. So the constant term is negative 1 times 2 times negative 3, which is positive 6. So when x is 0, which would be, say, here, y would be positive 6. So this point here is 6, if I had to sketch it. Now, that's just a real quick sketch. We haven't done calculus, so I actually don't know where this turns. But all I know is that it cuts through negative 2, 1, and 3, that it's that shape, that it's when I multiply the x terms together. So this is what we want to do. We want to multiply the x terms together to get the x cubed, to know if it's positive or negative. We want to multiply the constant terms together to know where it cuts the y-axis. Okay, so that's the general shape. I don't know what this point down here is, and I don't know what where it actually turns up here. I don't know. All right? All right, this one, if I multiply my x terms, sorry, not like that, but what do I get when I multiply my x terms? So the leading term, isn't it negative x times x, which is negative x cubed type? What's my constant? My constant term, I think it's going to be 0 because this is negative x plus 0. Okay, it's going to be 0 because of this. because I've really got to consider that as negative x plus 0 or negative x minus 0. Constant term should be 0. Well, it will be, because where are your x-intercepts? Looking at these, what are they? 0, 1, and negative 3. So, what's the shape? This shape. That shape. Not that shape. That's the positive x cubed type. This is the negative x cubed type. Crosses at negative 3, 0, and 1, and it's this shape. Okay? But that's the general shape. The y-axis would be here as well, because because one of the x-intercepts is 0. When x is 0, you're also going to have y is 0, because 0 times negative 1 times 3 is 0. If you've got an x-intercept of 0, the y-intercept's 0. All right? Okay, so this type is like that. So that's that shape. This is that shape. We okay? Now, a double root. This still has degree what? What's the degree of this? It still is degree 3, because that's really x minus 1 times x plus 2 times x plus 2. So it is degree 3. What is the leading term? You multiply the x's, you get x to the power of 3. So it is a positive x cubed type. But instead of going like this, like it does go like this, but it's where you've got the double root, the graph bounces off the x-axis like a parabola. So, but where are our x-intercepts? Where are they? 1 and negative 2. But we have a single root. We have a single root at 1, but we have what's called a double root at negative 2. Do you know why it's a double root? Because it's x plus 2 squared. So this one is a double root. There's a single root at 1. So I'm going to put where my roots are. I've got roots at negative 2 and 1. My general shape has to be like that, but it bounces. Sorry, let me just go back up here for a minute. Single roots. The graph cuts through the x-axis, so it'll cut through like that, or like this, or like that. It'll either cut through the axis like that or like that. See how it just cuts through where the x-intercepts are, right? But what we mean by a double root is that it'll bounce off. So let's say you've got a double root here. It'll either bounce off like that or bounce off like this. It's either going to bounce from below or bounce above. That's what we get for the double root. That's how it touches the x-axis at that point. Now, how am I going to keep that shape? And I've got a double root at negative 2 and a single root at 1. I have to just cut through 1 but bounce off 2. If I want to keep this shape, it's got to go like bounce there and back up here. Do you see? It's got to bounce off negative 2. I can't. The shape is like this because it's a positive leading coefficient of the cubic. Now, so it bounces off negative 2. There's my double root. Are we okay with that double root? And there's my single root here. It cuts through at the single root. Now, just tell me what the, if we had to, I'm not sure exactly where it's going to turn either. So I'm not going to put the y-intercept at the moment. But what would be the y-intercept anyway? It's negative 4. So the y-intercept would be negative 1 times 2 is negative 4. But I don't know if the y-intercept is before it turns or after it turns. But down here it's about negative 4. But like I said, I'm not sure where this turns. But it does cut through at negative 4. Now, if you're not sure of how it goes, you know you've got a double root there. What you could do is substitute something like x is negative 3 into your equation. Let's say you forget what the shape is. And you're not sure if you start, you know it bounces off at negative 2, but you don't know if it bounces up like that or down like that. What you could do is substitute x is negative 3 into your equation. So I'm going to sub x is negative 3. And wouldn't I get negative 3 minus 1 is negative 4 times, if I put negative 3 in here, plus 2, that's negative 1 squared, that's a positive. It's down here. It's negative 4 times 1. It does start down there. So when x is negative 3, I've got a negative y value. So I know it starts down there. Do you get what I just did? That's how you can tell where it starts as well. Okay? This type here. So what's your leading term going to be? So be careful. I've got negative. This is x times x times x, negative x cubed type. Because it's negative, then x times an x times another x times another x, negative x cubed type. What are the x-intercepts? 1 and negative 2. Which one's the double root? So here is my double. I've got a double at 1, double root at 1, and a single root at negative 2. And it's the negative x cubed type, so it looks like this way. It looks like that. The shape looks like that, but it's going to bounce. So let's put them in, negative 2 and 1. I know it just cuts through at negative 2. And it's this type. So it cuts there, but it bounces off this one. So it's got to be like that. But you could check. For example, a good point to check would probably be, if that's x is 1, this would be x is 0. We should have a negative y-intercept. Let's have a look. Y-intercept. When x is 0, what do you get? Y is, don't you get negative 1 squared is positive 1 times 2, which is 2, and stick a negative in front of it, it's negative 2. Or you could have tried negative 3. If you substitute in negative 3, you should get a positive value. Okay? So negative 3 minus, well, whatever that is squared, that's positive, times negative 3, that's negative. Positive times a negative is a negative. Put another negative in front, that's a positive. Yes, it is up there. Okay? So it cuts through once, bounces off. Okay? We good? Now, triple roots. So, triple roots. At a triple root, the graph passes through the x-axis with an inflection. An inflection is the shape that you see on the graph y equals x cubed. This is an inflection, I'll show you. Like that. That's an inflection, or this way. That's what it'll look like. It'll have that little bit of a horizontally bit through like that. The graph goes like this, so it doesn't bounce. It's a triple root with power of 3. You know how your basic x cubed graph looks like that? It looks like the x cubed graph passing through the root. Either the positive x cubed graph or the negative x cubed graph. All right? So you can either cut through the axis, you can bounce off the axis with an x squared like a parabola, or you can do an inflection, and this is called an inflection, like the shape of the x cubed graph, the simplest x cubed graph, through the x-intercept. So let's have a look here. We've got a triple root at where? X is 1, and a single root at x is negative 2. But what type of graph is this? What's the degree? Well, yeah, the degree is positive 4. It is an x to the 4 type graph. It's a positive one. We know that looks like a W, but instead of coming back up for the W, it's sort of going to go, it's still going to have 4 sections, all right? Now, what we've got, but let's just put where our, see, when you've got triple roots, the shape does change a bit. Even with double roots, it sort of changes, but it only sort of changes because it bounces, but it still is that general shape with a double root. But with a triple root, it's not going to be exactly that W, all right? So, but there are going to be sort of 4 sections to it. So, where are our roots? Where do I put them? Negative 2 and 1. Now, we know it's the positive type, so it's a positive degree 4. So, where does it start? From up here or from down there? Yeah, it does, but let's just double check. Let's check. What would you try to check? X is negative 3. So test negative 3. So when x is negative 3, let's just have a look. So I get negative 3 minus 1 is negative 4 cubed. That's negative 64 times negative 3 times plus 2 is negative 1. Positive 64. Yes, it's up there. How am I going to go back through here? I've got to come back up and then I've got to do an inflection through it. It doesn't cut through it. It doesn't bounce off it. It does that S.
Stay on the line.
That where you go through 0 is where it goes that shape. Just like that. Okay? Now it sort of is 1, 2, 3, 4. All right? But because of the inflection, you don't see the 4 sections that well. It's 1, 2, 3. The third section is across, sort of. Not, still got to have a bit of a curve to it. But you get that you have that x cubed shape through 1. Yes, it's like the graph x cubed passing through 1. All right. Now, this one, the last one, what degree? Well, an x times x cubed, it's degree 4. The leading term, what is the leading term? Negative x times x times x times x. Yes? Because that's really x plus 2, x plus 2, x plus 2. Leading term will be negative x to the power of 4. It's a negative type. It's like this. But it's not going to be exactly like that because of the cubic. All right? So, let's see. Where do we have the double root? So, the x-intercepts are at 1 and negative 2. And we have the single root at 1 and the triple root at negative 2. Okay. Now, we could actually throw in, sorry, coming back to this one, the y-intercept would have to be negative here, wouldn't it? If that's 1 and that's negative 2, here's 0. Let's just look when x is 0, you get negative 1 cubed, sorry, y-intercept, negative 1 cubed times 2. Yeah, that makes sense, negative 2. Very good. Good idea to put it in. Let's look at this one. You can work out the y-intercept here before you start as well if you want. What's the y-intercept here? Be careful, you're multiplying the constant terms. Or you're substituting x is 0. What do you get? 1 times 2 cubed, it's 8. So it's obviously going to come from up here. The y-intercept's going to be up here somewhere. But let's draw this. We've got the negative type. So it starts from here. We've got a triple root at negative 2. So it's got to be that sort of inflection, yeah? It passes through negative 8. I'd say it's going to pass through on the way back down, but you don't have to know exactly where it passes. I'm just guessing that it probably passed through on the way back down rather than the way up. It doesn't matter. You don't have to know that. All right? But it passes there. We've got a single root at 1. Do you get that? We've got a triple root at negative 2. And if I substituted in x is negative 3, I would know it starts from down here. So sub x is negative 3. And I get, what, 1 minus negative 3, that's 4, times negative 3 plus 2, that's negative 1 cubed. Yeah, it's definitely negative. Starts down there, that's good. Triple root, see there's my triple inflection type. There's my single, it cuts through at 1. What have we got here? What's the degree? Leading coefficient? Degree 1, 2, 3, 4, 5, 6. Is it a positive? Positive leading coefficient. What else can we do? We've got a single root. So the roots are 0. We've got a single. What else? At 2, we've got a triple. And at negative 1, we've got a double. Oh, this is going to be fun. Okay, so we've got a single, a triple, a double. X to the power of 6, positive, upward like a 3-humped camel, sort of upside down, right? But it will be distorted because of the triple root. Okay, now let's just put where our roots are. Oh, by the way, where is the y-intercept while we're here? Yes, good. So we've got 0, we've got negative 1, and we've got the triple root at 2. So we've got to start on the left. So we've got a double root at negative 1. So we've got to decide, is it going to bounce up or bounce down? If you go purely by shape, because it's a positive, it should be up, like the positive x squared. It should be up, but it doesn't matter if you can't remember, because what you'll do is substitute x is negative 2 to check. When x is negative 2, you get negative 2 times, what do we get? Negative 4 cubed times negative 2 plus 1, negative 1 squared, which is just 1, and that's a positive. Whoops, you get a positive. Positive. So it's definitely, it bounces off, but does it bounce off like that or like this? Bounces off like that. At 0, I've got the single, it's just got to cut through, okay? And then at negative 1, at 2, I've got the triple, so it has to go back like this. Trying not to have it too flat there. And that's what it'll look like. Double root, single root, triple root. All good? What have we got here? So degree, what's the degree of this one? 5. Positive or negative? Negative, leading coefficient. So do they start? Just think of the negative x graph goes like this, right? So it starts from up. 1, 2, 3, 5. Anyway, it doesn't matter if you don't remember the shape. What have we got? The roots. We have -2, which is a double root, and we have another root at 3, which is a triple root. Okay, so we put -2 and 3 on the number line. You can put 0 in there somewhere if we want to work out the y-intercept. But we've got a double root at -2. It's either going to bounce up or bounce down. If you're not sure of the shape, let's just substitute x is -3. So when x is -3, what do we get? You get -1 squared, which is 1, and you get 6 cubed, which is positive. You get positive when x is -3. So it does bounce up for the double root. It doesn't pass through 0. I've just got it there at the moment. All right. You could work out what the y-intercept is. It's got to be positive. What do you get when x is 0? So the y-intercept is 2 squared times 27. 4 times 27. It's big. It's positive and big. 5,408. I hope. So it's up here somewhere, but then we come back down for the triple root at 3. It's got to go like that. It's the only thing it can do. Okay, so double root at -2, y-intercept, it does not matter where it turns, if it's turning before that or after it. I'm not sure. We haven't learnt how to find turning points yet. We do that later in the year. All right, but I know I've got a triple root at 3. Okay, and we know it's up, down. You know, the even ones are like up, up. Odd ones have one end up, one end down, the odd ones. All right. Are we good? Okay, next.
So, you know, with the overall...
So how do we know this shape? If we look at a negative power of 5 type, it's supposed to be like this. 1, 2, 3, 4, 5. It's sort of like that, a negative power of 5. See, negative cubed is like this. But this one has an inflection, so it won't be exactly like that. So it goes 1, 2, 3. It would have gone like that, but it's sort of across and down, okay, because of the cube root, because of the triple root, okay? It changes the shape. But with an odd, you have one up, one down. With the negative, it starts that way. You can think of a negative gradient, it starts like that. Negative ones start like that. Now, the next one, what degree? Got to be careful, you need to factorize it. So we've got x plus 1. Oh, factorize a few times. What have we got here? 2 minus x, 2 plus x, x minus 5, x plus 2. If you factorize. How are we with that? No double roots. You've got 5 single roots because I've factorized those 2 underlined expressions. Okay? So we've got, what's the degree? 1, 2, 3, 4, 5? Degree 5. Is it a positive or a negative? I've got a negative. Because it's multiply the x terms and you get x times negative x times x times x times x. Can you see it's a negative? So it's a negative leading coefficient. The leading coefficient is actually negative x to the power of 5 if you multiply all the x terms. Okay. So degree 5, all single roots. Where are your roots at? I've got -1. We've got 2. We've got -2. 0, 1, 2. Where else? 5. Have I got a double at -2? It looks like I do. Is this correct? X squared plus 2x minus 5x minus 10. Looks like I've got a double root at -2. So the roots are, I've got -1, I've got 2, I've got 5, and I've got -2 twice, from what I can see. Okay, so it looks like I've got a double root. So, all right, this is a negative, so it should start up here. But let's just double check. Because the negative types, because it's like the line y equals -x starts like, goes down. But let's substitute x is -3 and have a look. So when x is -3, what do you get? -3, you can go into this equation or this one, it doesn't matter. When x is -3, this will be a negative times, this will be 2 minus -3, which is positive. So I'm just going to go negative times a positive. When x is -3, I've got another negative there. When x is -3, another negative, sorry, just negative, I'm just going to put minus, not -1, and negative. Looks like I've got 1, 2, 3, 4 negatives and a positive. So if I put x is -3 in here, that's negative, that's negative, that's negative, that's positive, that's negative. 4 negatives multiplied by each other gives me a positive. That's correct. Okay, single root at 1, single root at 2, single root at 5. And that's what it looks like. We good? If you want, you can check negative, you can put in your y-intercept if you want, not sure exactly where it turns. But when x is 0, looks like we've got 1 times 4 times -10. No, yeah, when x is 0, 1 times 4 times -10, -40, if you need that. Okay? All right. And the last one. So we've got this. Where are your degree? What's your degree? Positive or negative? I've got negative x 4 times. I've got a positive x 3 times and a positive x once. To me, it looks positive. Are we okay with that or not? Positive leading coefficient. In other words, it should have 2 ends going up. Both up, and it starts, it's like x squared. Think of the x squared graph like that, but you can always substitute. We've got our roots at where? 0, where else? -2, no, -3 on 2, -1.5, and 1. Now, an x to the power of 4 is just a very steep x squared. If I sketch y equals x to the power of 4 just on its own, if I just sketch, look, I'll just show you down here. Y equals x squared, just the ordinary graph looks like that. Just the ordinary graph with no other x's. Y equals x to the power of 4 is just a very steep version of that, that's all. Okay, it's just a steeper version. For example, when x is 2, y is 16, rather than when x is 2, y is 4 on this one. That is just the ordinary x to the power of 4 graph. So, I haven't shown you a quartic root. All right? We have a, what have we got here? A triple root there, a single root here, and this is a quadruple root. Now, a quadruple root is just a very steep version of the double root. That's all. It's just steeper. So let's draw it. We've got a root at 0, a root at 1, and a root at -3 on 2. We know we've got a triple root at -3 on 2. We've got a root at 0, so that's my y-intercept. All right. Okay. Do we start up here with a degree 8 positive? We do, because like x squared's like that, x to the 4's like that, x to the 6 is like that. So we should start up here. But how would you know? Let's just substitute x is -2 to make sure. X is -2. I've got negative. X is -2. That's -4 plus 3. That's -1 cubed is negative. X is -2. That's positive. It's definitely positive. I've already cubed that. 1 minus negative 3 is positive 4 to the 4. I'm substituting x is 2. I get a positive answer. It's definitely like that. I've got a single root at 0, and I've got a... Sorry, I'm so sorry. Triple, yeah, sorry. I'm not reading it right. Sorry, triple root, yep. Inflection, got it? Back up for a single here. And then we've got a quadruple root, which would bounce very steeply up. Okay, now, sorry everyone, inflection. Now, I know when x is negative 2, it's positive. If I tried, say, x is negative 1, I should get a negative value. So you can always check any section of the graph if you're not sure. If I'm not sure, let's say I made that mistake. If I try x is negative 1, I get negative 1 times, that's positive. And negative 1 here is positive. Yes, it's down here. All right, that's my single root, that's my quadruple root. If you're not sure here what happens, why don't you just try x is 2 and make sure it bounces back up? Got it? You could try x is a half and make sure it's up here as well. Do you get it? So x is 2 gives me 2 positive. That would be positive. This would be negative to the power of 4, which is positive. Yes, it's up. You can substitute in any section, but let me tell you, you haven't got time to substitute 4 sections. You've only got time to substitute 1 or maybe 2, all right?